Hi, my name is Sourav Saha. I am a faculty member at the Florida State University in the Department of Chemistry and Biochemistry. In this SES video, I'll talk about a new supramolecular interaction between anions and biacidic naphthalene diimide, in short, NDI compounds. So NDI molecules are biacidic, which you can see from the electrostatic potential map, because the whole pi surface is blue and the electron concentration of the electron is on the carbonyl oxygen atoms. Because it is electron deficient, it also has a low-lying LUMO level at -4 electron volt. Taking advantage of that electron deficiency, it can interact with the pi-electron-rich aromatic compounds such as naphthalene and pyrene to make charge transfer donor-acceptor complexes. And supramolecular chemists actually took advantage of those kind of complexes to make different supramolecular materials such as ADMRs, rotaxanes and catenanes, and self-healing supramolecular polymers. However, the anion recognition property of NDI molecules are relatively underexplored. Matthijl and co-workers have developed anion pi slides using the NDI rod molecules that they used to transport chloride ions across artificial membranes. We postulated that these pi-electron deficient NDI compounds may interact with certain anions through a charge transfer or electron transfer interaction and change their optical and electronic property. To test our hypothesis, we screened several anions with this NDI molecule. You can see here that only fluoride ion changed the color of NDI from colorless to pink when the concentration of fluoride was too large. However, the other anions did not change the color of the NDI receptor. To understand what is going on, we actually took advantage of DFT calculation, which shows that the fluoride ion is located above the imide ring of the NDI molecule, about 1.64 angstrom above the carbonyl oxygen, and it transfers about 3.3 electron from its lone pair orbitals to the NDI pi star, more specifically the carbonyl oxygen pi star orbital. And that was done in collaboration with my colleague Igor Alabugin using NBO calculation. To quantify that colorimetric changes, we actually did a titration experiment which we monitored by UV-Vis absorption spectroscopy. In this case, the NDI itself is colorless, which absorbs in the UV range. You can see that from the black spectrum. When we titrated this molecule with fluoride, it turned, first at low concentration of fluoride, it turned orange, and it produced that orange spectrum. When we added more fluoride, it turned pink and produced that pink spectrum. By comparing this spectrum with the spectroelectrochemistry data of the NDI molecule in the absence of fluoride, we confirmed that in the presence of small amount of fluoride, when it binds to NDI, it transfers an electron to the NDI LUMO to produce the radical anion, which is orange in color. And at higher concentration of fluoride, a second fluoride transfers another electron to that radical anion to generate a pink-colored dianion. We then postulated that the affinity and sensitivity of the NDI receptors may be improved if we pre-organize two of these NDI components in a single receptor molecule in which two NDIs will be overlapping with each other in a parallel fashion. To test that hypothesis, we used fluorescence spectroscopy and look at the change in fluorescence intensity of these NDI receptors in the presence of fluoride. Here we see that the minimum concentration of the monomeric NDI had to be 10 micromolar in order to visualize any fluorescence amplification. However, in the case of pre-organized bis NDI receptor, we could go down to as low as 1 nanomolar concentration of the receptor molecule, which showed the similar fluorescence amplification. And we confirm this again with NMR and isothermal titration calorimetry, which are discussed in details in the JACS paper. So I'll finish this SES video by showing you a cool demonstration of an application of the NDI receptor using fluoridated and non-fluoridated toothpaste. The children toothpaste, which is not fluoridated, when it was treated with the receptor molecule, it did not show any colorimetric change or spectroscopic change. However, treatment of the same receptor molecule with a fluoride containing anti-cavity adult toothpaste produced this orange spectrum, which is same as the radical anion spectrum of NDI molecule. So potentially the NDI fluoride interaction can be used to detect fluoride in practical sources. With that, I'll finish this SES video. Thank you very much for listening and your patience.